my name is María Rivas, and I'm going to be solving problems from stage 1. So the first example that we have here is 60 meters over seconds. We want to pass it to kilometers over hours. So the first thing that we have to do is to pass meter to kilometer. So 60 meters over second will be 1 kilometer over 1,000 meters. Then we're going to pass seconds to hours. So 3,600 seconds over 1 hour. Then we are going to multiply all this and divide it, and we're going to have as a result 57,600 over 1,000. So then we are going to cancel the units. Meters and meters, seconds and seconds. So we have kilometers and hours. So it will be kilometer over hours. And then we divide it, and our answer will be 57.6 kilometers over hour. That will be our answer for our first problem. Our second problem is going to be, we want to convert 50 miles over hour to meters over second. So we have to do 3 things here. We need to convert miles to kilometers to meters, and then hour to seconds. So 50 miles, it will be 1 kilometer, and 1 kilometer is equal to 0.62100 miles. And then 1,000 meters is going to be 1 kilometer. So we passed miles to kilometers to meters. And then 1 hour over 60 minutes will be 1 minute and 60 seconds. So we pass hours to seconds. Now we cancel miles with miles, kilometers with kilometers. Then we cancel minutes, and hour with hour. Then we have meters and seconds. So we multiply all this and divide it, and the answer will be 22.36 meters over seconds. And that will be our answer to problem number 2. The third example that we have is where we want to pass centimeters to millimeters. So the example that we're going to use is going to be 90 centimeters. We want to pass it to millimeters. So we have to know how much a centimeter is a millimeter. So 1 centimeter is 10 millimeters. So if we want to pass 90 to millimeters, we have to multiply it by 10. So 90 by 10 is going to be 900 millimeters. And with that, we conclude stage 1.
Today we are going to talk about a topic of the stage 2 named resultant vector. For this, first we are going to resolve this problem. The problem says if a displacement of 30 meters east is added another 15 meters to east, the resultant vector will be. For that, first we need the data. The data are the first 30 meters to east, that is like 30 meters east, and then the other data that are 15 meters east. Well, now that we have the data, we are going to do the procedure. To obtain a resultant vector of vectors that have the same direction, we just have to do A plus B. That means 3 plus 15. And we obtain 45 meters. Then for obtaining the result, just we write the 45 meters. And for the direction, when two vectors are going to the same direction, the final direction will be the same. That means to east. And okay, for the second problem, we are going to talk about how to obtain the resultant vector of vectors of opposite direction. For this, we have this problem. If a displacement of 45 meters to the north is added another one of 60 meters to the south, the resultant vector will be. For this, we first have to put the data that are 45 meters to the north, and 60 meters to the south. Here the procedure just changes a bit. To obtain the resultant vector of this, we just have to rest A minus B. That means A will be the vector with the highest, with a big amount of meters or that. So we have to do it like this, 60 minus 45, and the resultant vector will be 15. Then when we put the result, we just have to put the same, 15 meters, and the direction will be the one of the vector with the bigger vector, so is south to south. And we're done.
Well, today I'm going to show you how to calculate the resultant vector of vectors that forms an angle of 90 degrees. So first the problem says, a boy is heading towards a football soccer camp and he walks 2 kilometers to east and then walks 4 kilometers to north. Calculate the magnitude and direction of the resultant vector. So first, the data is 2 kilometers to east and then he walks 4 kilometers to north. So he walks to east, 2 kilometers, and then to north, 4 kilometers. So to calculate the magnitude, here we have two formulas. So first, we put the y to the square plus x to the square. And the vector is 44.47. Or you can use in the calculator this formula, and here you can see that we have the result and the direction. So to get the direction, we can and 4 divided by 2, and then the direction is 63.4. So in the second problem, here we have two vectors, and the first one is in the first quadrant and the second one is in the second quadrant. So first, to get the resultant, the magnitude and the direction, we need to make this chart, and we need to write first the magnitude of the and then the angle, and then to get the x, we write the magnitude by cosine and by the angle, and then we have 86.6, and the same in the second one. to get the y, we do the same, but with sign. So then we add the first one and the second one, or rest it. Then we get 46.6, and here 50 plus 69 plus 2, 119. And then we do the formula that I already told you of the pole. 46.6, comma, and then we got the vector and the direction.
Okay. The next problem is stage 3 of uniform linear motion. Okay. The following problem is, in a baseball park, the distance from the pitcher's mound to home plate is 18.5 meters. If the pitcher can throw a ball at 50 meters per second, and considering that the speed is constant, how long does the ball take to reach plate? Well, our data is that the distance is of 18.5 meters and velocity is 50 meters per second. Then it's asking us for time. Therefore, we could say that we know that the formula for time is distance times velocity. Therefore, it's 18.5 meters divided into 40, that giving us the following. It gives us 0.4725 seconds. So for the next problem, we're going to talk about uniform acceleration motion. And the problem says, a car travels at a speed of 72 kilometers per hour. It slowly stops at the time of 5 seconds. Determine acceleration and distance before stopping. So our data says that the initial velocity is 72 kilometers per hour, or 20 meters per second. It also says that the final velocity is 0 since it stops. Then that time is 5 seconds. It is asking us for acceleration and distance. So we know that the formula for acceleration is the following. It's final velocity minus initial velocity, then divided into time. So it will be, we were going to use meters per second. It's going to be like this. 0 minus 20 divided into 5, that is minus 20 divided into 5, that giving us acceleration of minus 4. Then it's asking us for distance before stopping. So the formula for distance is this one. Is initial velocity plus final velocity divided into 2 times time. So it will be 20 plus 0 divided into 2 plus 5. That being 20 divided into 2, 10. Plus 5, 50 meters. And here being meters per second squared.
Now I'm going to explain some problems of the stage 3. The first one is about free fall. So the problem says, a freely dropped body reaches the ground with a velocity of 29.4 meters per second. So this problem is asking you to determine the fall time and the height from which it was dropped. That would be the distance. So we know that in free fall, a very important factor is the gravity. So we know that gravity is always 9.8 meters per second squared. Also, we have the data of the velocity, which is 29.4
meters per second.
So to get the fall time, we know that the formula to get final velocity in the free fall, we know that is gravity times time. So all we gotta do is put on the data in that formula and then search for the t, which is what we are looking for. So you would put 29.4 equals gravity, which is 9.8 times 10. And since 9.8 is multiplying t, you're going to pass dividing to 29.4. So it would be like this. So you do the operations, and as time, we have 3 seconds. Next is asking us for the height. That means the distance. And we know that the formula of the distance is y, which is distance, equals gravity, 10 times squared, over 2. So all we gotta do is put on the data in that formula and get the distance. So it would be y equals gravity, which is 9.8, times 3 squared, because we already got the time, over 2. You do the operations, and the distance would be 44.1 meters.
Now I'm going to explain a problem about vertical throw. The problem says, a baseball is thrown straight up and recovers 9 seconds later by the catcher. We have to determine the maximum height reached and the velocity after it was hit by the bat. So the first thing that you want to do to start solving these type of problems, like from vertical throw, is to make like a graphical representation. So this will be it. This is the trajectory that the ball followed, 0 seconds because it hasn't been thrown yet, and when it was catched by the catcher, the total time was 9 seconds. So we can assume that in the middle, which is the maximum height that the ball reached, was 4.5 seconds. So we know that the total time is 9 seconds. We don't know the velocity. They are asking for the velocity. We also don't know the height, which is another thing that they are asking for. But we know that always the gravity equals 9.8 meters per second squared. So the first thing that we want to do is to get the velocity. The formula to get velocity is gravity times time. So in these type of problems, you want to split in half the trajectory. So we will work with this half. So we know that the gravity is 9.8, and the time that it took in this half was 4.5 seconds. Here, some 4.5 seconds, and here, another 4.5 seconds. So 9.8 times 4.5, the velocity equals 44.1 meters per second. That would be the letter B, 44.1 meters. Now, to get the height, we just want to follow the next formula, which is height equals gravity times time squared over 2, which it would be final velocity times over 2 times time. So we will just put the data that we already got, which is final velocity 44.1 over 2 times the 4.5 seconds. So the maximum height would be 99.225 meters. And we're done.
Okay, today I'm going to talk about the stage 4, and it is one of problem of this topic, the horizontal motion. And the problem says a ball is thrown horizontally with a velocity of 3.7 meters per second by a person that is at a certain height respect to the ground. If the ball falls to the ground at 3 meters from where it was launched, how much time does the ball take to reach the ground, and what was the height when it was launched? And the following data that the problem says is the okay. In this problem, I have two variables. That is the time and the height. Okay. To answer the time, I need to follow in this formula. And if I isolate the time in the formula, I will have the time will be equal to x over b bu x. Okay. If I change the values of the variables, I will have the time. That time is equal to 3 over 3.7. And if I make the operation, the time is equal to 0.81 seconds. To obtain the height in the problem, I need this formula. So if I change the values, at the end I have this formula, this little formula. So I can change more values in the formula. So if I make the operations, I will have that the height is 3.2 meters. Okay, I'm going to talk about the parabolic motion, and one problem of this topic it says a golf player hits a golf ball using his golf club with a velocity of 30 meters per second with an angle of 64 respect the horizontal. Calculate the time that it reached its highest point, its maximum height reached, and its range. So I have this data, and okay, to obtain the time, I need this formula, and if I isolate the formula to have the time, the formula will be something like this. and if I change the values, the time will be 2.75 seconds. Okay, to obtain the maximum height, I will need this formula, and if I change the values that I have, and if I make the operations, the maximum height is 37.08 meters. Okay, to obtain the range, first I need the horizontal velocity, and to take it, I need this formula, and if I change the values, the horizontal velocity will be 13.15 meters per second. And I know that the time is 2.75, but the range is twice as at the time, and the whole time is 2.75 times 2, and the value is 5.5 seconds, and these two answers are the values that I need. Okay, finally, if I change the values, the last equation that I will have is this one. And the answer is 72.32 meters.